Yeah.
You see what I mean? Because when you multiply by 4, this is what you have. 4 secant squared minus 4. You see what I mean? Right? Now, can any one of you do each of the individual integrals, or you want me to help you guys? You want me to help you, or do you think you can do it, guys? You can do it? Yes?
Oh, possibly.
All right, tell me the first one. 9x. Next one. 12.
Isn't it
No,
the
it's not secant
derivative?
squared. That would be the derivative. You're looking in the wrong section.
Log secant squared x.
ln of secant of x, right? Plus, see, I got you, 4 tangent of x. See, piece of cake. This is for babies, right? This is for embryos, really, right, guys? You should be like, oh my goodness, this is so easy. All right, I think you start to feel a little bit more confident, right, guys? Graph. Oh, this is a hard one. All right, go for it. That's going to be a problem like find the area between these two curves. All right, go ahead. Graph it. The bigger your graph, the better you are going to approach the problem. The bigger your graph, the better you approach the problem. All right. Just remember how the sine goes and how the cosine goes. I'm going to do a small graph here.
Perfect.
The sine goes like this. And this is 0. And this is, can someone tell me what is this? Starts with 2.
2 pi.
2 pi, very good. Is this sine or cosine?
Sine.
Sine. Right, guys? How about the cosine of x? How does it go, guys? Starts at 1 and goes at 1. And what is this line right here? What is this number?
Square root of 3 over 2.
No, this is 2 pi. Not square root of 3 over 2. It's cosine of x. Alright. Now that you have the two graphs, you can graph them in the region that you want. Check which region you want, guys. Check the region that you want. Alright, go ahead, guys. Draw it. Draw them. Talk to each other and make the draw nicely. The bigger the graph, the better. If your graph is small, make a huge graph. A huge graph. And you have to make both functions on the same, both graphs on the same picture, right, guys?
What was this?
No, that one was on.
You guys want to talk to you?
That's over.
No, that,
No, when I talk to him, because he's the other child.
That was the
yeah, I sang one, and I remember it was wrong.
I know, I got 2 and I wasn't sure.
I think it's
What is 1 equals cosine?
So I put this.
Oh, there are 4 functions.
This is
Sine, cosine, pi over 4.
It's 2 from 1.
Yes.
He's a tutor.
Because each
I don't know how either, but he just said he's a
middle
tutor.
pi.
Well, we're trying to find pi
I
over 4,
figured that
right?
you're supposed to graph them both together to figure out where they're bound, and I think it's
So
going to be
this
this
is 2
area.
pi.
I think.
pi over 4 is significant because this is, if this is 2 pi, this is 1 pi, this is half pi, pi over 4 is right here.
So do you know the maximum and minimum values of
2
sine
pi.
and cosine?
1 pi is in the middle.
How do we know like how the points go lined up?
What is that coming
That's 2 pi.
This is 2 pi, so this is half of it.
There's
Personally, I
This is
like
pi.
4 pi.
So the
Yeah, check
maximum,
it out,
of
pi
course,
there.
adds pi over 2
quarter pi.
And so here, again, the size
The
goes pi.
max value
I just
is
did it.
one,
And
and
it
the
hits
minimum
0
value
at
Just beyond 4
pi.
quarters,
So
so
that
it's
means
right
at
here.
this point
Quarter.
right here,
Quarter.
yeah, this is
Yeah,
negative.
that's what I meant.
Now,
A quarter.
we want to find what point, what the x value gives us 1, pretty much. So, do you know?
Yes, sir.
I kind of think I'm understanding, but are we supposed to find an area that's overlapping with all of these or something?
Yes,
Is that what we're
like,
supposed to do?
like the area bounded, like you have like 4 functions like this.
Yeah,
1, 2, 3, 4. Like the area bounded by the 4
Yeah.
functions.
is that it there? Or did you find it?
That's a good one.
And
Like,
consider
that's
the
it?
distance we go in this
Cool.
direction.
that's a very good picture. I like it.
And so this part is blocked off by the
And the
5
distance
pi
of
over
your
4.
sine.
Okay, I
So you
see.
have like 4 boundaries.
Got
It's
it.
a sine graph.
You did it perfect, Mike.
So,
You got it.
consider 1 page.
Nice picture, Brandon. Nice picture, man. You're rock.
Sine of pi
Yeah,
over
good
2.
job.
You know the plans that your picture was very tiny.
Yeah, I probably should draw big pictures like him, huh? On graph paper
And right
too.
here, negative 1.
There's graph paper on the on your reader,
Once you figure that out,
all the way in the
it's
back.
pretty easy because you just take the integral of this and then
Ah.
basically
Oh,
take
nice.
pretty easy
That
to
is
plug it in
nice.
for x, and that's why you
So,
get that math
might
down
not
here.
be, so that I just said that it's.
Guys, use this
If you
graph,
look here,
the graph paper on the back, so your graph looks
0 right
neat.
here, pi.
See what I mean, guys?
So this is 1 plus 1x. This is 0, this is 2 pi. Oh, sorry, you're not here.
You just keep going until
Yeah.
5 pi.
All right, I'm going to go ahead and graph the functions, and that's it. So the cosine,
Right here.
someone tell me, how do you know where it goes? Like, if this is 2 pi, half of it is pi.
Oh yeah.
Half of it is pi over 2, so it hits 0 right there. So I'm going to do, so this point, and for the sine, this is 2 pi, half of it is pi, half of it is pi over 2, so the maximum occurs at pi over 2. So I know that this guy
Cool, thank
is
you.
pi over 2. Right, this guy is pi over 2.
Something like this, we can add that in the formula.
Yeah. The unit circle.
And this is pi. Now the cosine starts on the top, starts right here. Right here, the cosine starts, and it hits 0 at pi over 2, and it continues. It hits -1 at pi. So at pi, it should hit like -1 right here. It goes like this. Are you guys following? Right? And then it hits -1 like this. Oh, beautiful graph, guys. Right? And say, oh shoot, where do they meet? There is a point where the sine and cosine have the same value. What is that guy?
Pi over 4.
5
This is pi over 4, right? And then where's the other, okay, what's the problem? X equals what? So I have two curves. I'm going to do the other one in green. X equals what? The area bound x equals pi over 4. Oh, is this line right here? Oh, shit. Sine x equals pi over 4. Right? Is this line right here? What's the other line? X equals what?
5 pi.
5 pi over 4 is the same as pi. Pi plus pi over 4, right? So this line should continue. 5 pi over 4 is somewhere here. You guys agree? So let me continue with the graph. Right? And this is supposed to be pi over 2, 3 pi over 2, and it derives all the way up to, this is 2 pi. Right? Whereas the sine continues. Sine continues. Right? this is like 3 pi over 2, this is the minimum. Goes like this. So 5 pi over 4 is right where they meet again, right here. So x equals 5 pi over 4. This is pi plus pi over 4. It's like by symmetry, guys. So what happens here is what happens here. So what is the area that they want, guys? Is that y equals what? 5 pi over 4? X equals 5 pi over 4. Pi plus pi over 4, yeah. So I think this is the area they want. Do you guys agree? This is the area. First you shade it. Brandon, is that the area, the same area? Almost? Pretty much? Okay, I think the most interesting, the hardest part is probably to do the graphic. Alright, now the answer is the following. Is the integral from where to where, guys? What do you think? From where to where?
Pi over 4.
From pi over 4 all the way up to
5 pi over 4.
5 pi over 4. And what goes here? Here goes the bigger function minus the smaller function. What's the bigger function within this range? What's the bigger function? Sine of x. Minus the smaller function. What's the smaller function, guys? Cosine of x. dx. And you might say, Professor, how do you know that the sine is bigger than the cosine? Well, probably you have to graph them. Okay, so you do, let's compute it. So this is the integral of this, forget about this limit for a second. What's the integral of sine? What is the integral of sine? Okay, let's do it like this. Integral of sine minus the integral of cosine of x dx. So let's go ahead and do it, guys. What is it? What's the integral of sine?
Negative cosine.
Negative cosine. What's the integral minus? What's the integral of cosine? Just sine of x. Once you're there, you say evaluate it from x equals pi over 4 up to x equals 5 pi over 4. Right? And so you go equals, plug this information, plug this number into this expression, so it's going to be minus cosine of pi over 4. No, what is it? 5 pi over 4. Minus sine, there are going to be lots of minuses, sine of pi of 5 pi over 4. That expression. And then guys, I forgot the rest of the brown, guys, please help me. Minus the same expression, right? But this time plug the lower limit. It's going to be negative cosine of pi over 4, then minus sine of pi over 4. Now we know the values. We know the value. What is the sine of pi over 4 from this graph? What is going to be this graph, guys? You have a little table with sine and cosine that you can use in the test. What is it? Sine of x, and there is pi 0, pi over 4, pi over 3, pi over 2, pi over 6, and something like that. And what are the values for the sine? This is 0, this is 1. What is the sine of pi over 4, guys? Square root of 2 over 2, right? So the answer is, this is square root of 2 over 2. This is square root of 2 over 2. And this is by symmetry, you can tell it's going to be minus square root of 2 over 2. Otherwise, you can also use the a little table, or you can use the sum of the sine and cosine of the sum of two angles. But this is minus square root of 2 over 2. Or you can subtract pi and put a minus in front of it. All right, and so you got I think this is the whole answer, but it's nice if you go minus times minus is plus, square root of 2 over 2. And then minus times minus plus square root of 2 over 2. And then this is minus times minus plus square root of 2 over 2. And then minus times minus plus square root of 2 over 2. So the final answer is that. Actually, you can simplify it. This is the same as 1 banana plus 1 banana plus 1 banana plus 1 banana. How much is it? 4 bananas, right? So this is the same as 4 times square root of 2 over 2, which is the same as 2 square root of 2. Yes? Is that what you got, guys, in your problem?